and we don't know GK. So the length of PQ is equal to 1/2 the sum of the two bases. That's HJ and GK. So you just plug in with the values. So 28 is the average of 40 in our unknown. To get rid of this 1/2, we divide both sides by 1/2. Dividing by 1/2 is the same thing as multiplying by 2. So, on the left-hand side, I'm going to get that this is 56 equals 40 plus x. Subtract 40 from both sides, and x is 16. That is x was representing the length of GK. Do you agree? If you don't like messing with that 1/2, that's okay. Like, you can just say that 2 of these medians in this trapezoid is equal to the sum of the lengths of your two bases. That's perfectly fine as well. You would have had the same answer, that x is equal to 16. And you would use this exact same formula for part B. Exact same formula. I'll plug it into this one. So 2 of PQ, so this is 5x minus 9 is equal to HJ, which is 5x. And once again, we don't, we're given that. So 3x plus 2. So that's just me plugging into the formula. I got 10x minus 18 is equal to 8x plus 2. 2x is equal to 20, so x is equal to 10. Yeah? Sweet. And then number 4, really quickly, we forgot something. Part A says angle ONJ is congruent to what angle? I cannot say this enough. Whenever you have parallel lines, you're going to be using those angles, alternate interior, alternate exterior, corresponding, and same side interior angles. If you're dealing with trapezoids, you have exactly one pair of parallel sides. In this case, those two are parallel. So look at what is forming this angle. Angle ONJ is right here. That's this segment, which is one of the ones that's parallel, and then it's this segment, which happens to be a transversal. Now I understand that if you look at this diagram, there's 4 transversals. You've got OJ, you can consider that a transversal, or OE, or the one we're actually looking at, JN, or EN. But whenever you see this diagram, you need to isolate your parallel lines and one transversal. So right now we're isolating segment JN. So when you do that, you need to look through all the muck and the mire and just see this. I've got 2 lines that are parallel, cut by 1 transversal. And from there you've got all your alternate interior, alternate exterior, corresponding angles that are congruent. So these 2 are alternate interior angles, and in the diagram, that is this angle here, NJE. And that's the one that it is congruent to. The justification, the reason is because when lines are parallel, then I can conclude, my conclusion is that alternate interior angles are congruent. So again, make sure your justification matches up. By saying these 2 segments are congruent, that means this is an isosceles triangle. So that means that segment OE, which is one of the diagonals, is congruent to the other diagonal, segment NJ. If this is true, again, then that means it's an isosceles triangle, isosceles trapezoid. Then this angle NEJ, that's one of your base angles here, is congruent to angle OJE, because if you have an isosceles trapezoid, then your base angles are congruent. Okay, get out a grid breaking pen. We're going to look over these answers. Anyways, yeah, we got to memorize all the properties about kites. The diagonals are perpendicular. Be able to prove that. And then also, you have a pair of opposite angles that are congruent. The other pair of opposite angles will be bisected by the diagonals. One of the diagonals is being bisected by the other. Just all those properties about kites. It's not going to go away. You need to memorize that. And then we learned about trapezoids. So, by definition, a trapezoid has exactly one pair of parallel sides. Then you have the 2 pairs of consecutive supplementary angles all the time, because they're same side interior angles. And then if it happens to be isosceles, then your diagonals are congruent. Your base angles are congruent. Now we're just going to be piling on more information. So we're talking about parallelograms. Parallelograms, obviously, just by the name, what's unique about this quadrilateral is both pairs of opposite sides are parallel. So if you want to prove that a quadrilateral is a parallelogram, go back to the definition. You need to show that both pairs of opposite sides are parallel. For the sake of brevity, the symbol that can be used for parallelograms. So we're not just getting cramped just writing the word parallelogram all over the time. We're just going to use this symbol. Just resembles a parallelogram. This word here, brevity, does anyone know what that means?
Brief.
Right, brief, short. Short and sweet. I know some people, like, if you ever send an email from your phone, I mean, I don't know if you guys send emails, but it has that little signature and it says, oh, it's sent from my iPhone, or it's sent from my iPad. Has anyone ever seen that? Like, some people add to that, and they'll say, like, oh, excuse my typos, because I'm on the phone, or whatever. I know some people that say, like, pardon the typos and brevity. Just meaning, like, sorry it was so short, I'm just on my phone. So yeah, brevity just means short and sweet. Anyway, so know the symbol for it and know the definition that both pairs of opposite sides are parallel. But we're going to be learning a lot, improving a lot of properties about these parallelograms. So let's just dive right into it. It says given parallelogram KATY as shown. So just from this alone, that they tell us it's a parallelogram, we know that segment KA is parallel to segment YT. That's from the definition. And we also know that, using different colors, the other set of opposite sides. It means segment KY is parallel to segment AT. Simply by the definition, the fact that they told us it was a parallelogram, that's what we know. So then part A asks us, which angles are consecutive to angle K? So think to yourself, which angles, notice how it's plural. Which angles are consecutive to angle K? This was another reason why day one of, this was like 15-1, I told you, you need to get in the habit of being able to find these quickly. Consecutive angles, opposite angles, consecutive sides, so on and so forth. So, Grace, give me one. Angle K is consecutive to angle? Y. Because I asked. Just checking. Angle Y, correct. And then some of us are now getting it, that's okay. And then the other one, angle K is consecutive to which angle as well? We'll go with Tyler?
Angle A.
Angle A, very good, sir. So we got angle A as well. So then it says, use what you know about parallel lines to complete this theorem. That consecutive angles, like angle K and angle A, also like angle Y and angle K, consecutive angles of parallelograms are what?
Supplementary.
Supplementary. How do you know that they are supplementary? Is that Grace?
Same side.
Yes, yes ma'am. So, if I'm considering these segments that are parallel, I have this segment as a transversal. And so, these two angles that are same side interior angles, they're not congruent, but I know that they have to be supplementary. And because the justification is, if lines are parallel, then same side interior angles, are supplementary. So that works for these two angles, angle Y and angle K, but however, let's talk about angle K and angle A. Well, with that, we're going to have to consider the other pair of parallel lines. We're going to have to look at these guys. So when I have these two lines that are parallel, and it's being cut by this transversal here, then now these two angles are same side interior angles, and those have to be supplementary when lines are parallel. So it's the same justification, it's the same reasoning that when lines are parallel, then same side interior angles are supplementary, but you have to use the two different sets of parallel lines to justify both statements, that these two are supplementary and those two are supplementary. That's going to come up in proofs. So the fact that this right here, since this is true, this implies that angle K and angle Y, these two are supplementary because these lines are parallel. Same thing with angle A and angle T. However, these blue lines, because those are parallel, this justifies that angle K and A are supplementary, and also angle Y and angle T. So that shows that all four of the consecutive angles, all four pairs, are supplementary. But you have to understand what implies that. And it's using both sets of these parallel lines. So know which one comes from which. Okay. Item 2, we're not going to do this because I got like 140 of you kiddos. And so to give every single one of you 3 index cards, that's a lot of index cards. And that's a lot of cutting up and trash all over my room. And we ain't doing that. So we're just going to talk. We're going to talk right along this. Pretty much the activity is you cut a card, an index card, into 3 different parallelograms. But that's kind of a. They're being very optimistic about this because the definition of a parallelogram is that both pairs of opposite sides are parallel. And so that's pretty tricky to make 3 perfect yet not congruent parallelograms and then do like this exploration. So we're just going to stick with that. But we are going to talk about it. In item 3, it says based on this exploration, in item 2, complete the theorem. So what they wanted us to do is they wanted us to investigate these triangles created by these diagonals. So let's say that this was our parallelogram. By definition, we know that the opposite sides are parallel. And then we added in this diagonal, and we wanted to see what was happening with these 2 triangles that were created. And it doesn't matter what your parallelogram looked like, as long as it truly was a parallelogram. Every single time you added in one of the diagonals, the 2 triangles created should always be congruent. Always. And this is what? If I consider this set of opposite and parallel sides, then the angles, the alternate interior angles created by those 3 lines, the 2 that are parallel and the 1 transversal, I know that these 2 angles are congruent because what? When lines are parallel, alternate interior angles are congruent. Good. Now, if I look at the top and the bottom lines that are segments, the sides that are parallel, so I'm going to look at this line, and I look at this line, and we're still considering the same diagonal. So this guy right here, I have a different set of alternate interior angles. And you need to look at the angles that are being formed by the 2 parallel lines and the 1 transversal. So that's why these are. This angle is being formed by that line and then this transversal. And then this angle here is being formed by that line and that transversal. So it's a different set of alternate interior angles. Again, just as I stated before, you're gonna have to know which set of parallel lines creates the congruent angles. Because in a proof, you're gonna have to state, well, because these lines are parallel, that implies that these angles are congruent, and so on and so forth. So know which ones come from the parallel sides. Then I can say that these 2 triangles share this segment GI.